Though the genetic contribution to lifespan may be relatively minor, are there specific genes that have been associated with longevity? The leading method for complex genetic mapping is called genome-wide association analysis, which is essentially a massive game of Go Fish, comparing 1,000,000 or more letters of DNA between groups of similar people looking for a match. So for example, if you stretch out the DNA of hundreds of centenarians and compare those sequences to that of non-centenarians, is there a DNA letter at a certain position that centenarians share disproportionately? The problem is hundreds of centenarians are all researchers are typically able to find. Extremely long-lived individuals, such as centenarians, comprise only a tiny fraction of the population, on the order of 1 in 10,000 or so. As you can imagine, the more people you have in a genome-wide association study, the more likely you'll be able to find a needle in the DNA haystack. With so few people available to study for extreme longevity research, it becomes much more difficult to identify trends. Some researchers have tried solving this problem by lowering the age requirement to 85. Then you can enroll thousands into your study, but making it to 90 is not the same as making it to 100. In fact, statistically, it's as hard to get from 90 to 100 as it is to get to 90 in the first place. So, by using younger age brackets, we may miss out on discovering some secret centenarian sauce. That brings us to the largest genome-wide association study of lifespan to date, based on data from 1,000,000 people. How were researchers able to include so many subjects? By correlating the genetic fingerprints of 500,000 middle-aged individuals with the ages of both of their parents. They were able to find a dozen DNA regions linked to lifespan that appeared to account for up to 5 years difference between individuals. 12 DNA markers is actually a surprisingly low number, compared to height, for example, which is determined by more than 400 different DNA spots, although unlike lifespan, height is highly heritable. A review of all the genome-wide association studies for longevity put together only found one gene confirmed in multiple independent meta-analyses, the Alzheimer's gene, ApoE. Beyond just determining lower or higher dementia risk, ApoE is the single most important gene when it comes to longevity, though again, that's not necessarily saying much. ApoE codes for a protein that is 299 amino acids long, called apolipoprotein E. Some people have ApoE genes that code for the protein with the amino acid cysteine at positions 112 and 158, known as the ApoE2 variant, while others have an arginine in those spots, the ApoE4 variant of the protein, and ApoE3 is the third major type of variant, which has one of each. Having genes that code for the ApoE4 variant increases your risk of cognitive decline, full-blown Alzheimer's disease, and premature death. If you have one copy of the ApoE4 gene from your mother or father, your odds of becoming a centenarian are cut roughly in half. And if you have ApoE4 genes from both parents, your centenarian odds drop by more than 80%. What does this protein do to have such a powerful impact on our health and longevity? ApoE is the primary cholesterol carrier in the brain. It plays a major role packaging and transporting LDL cholesterol throughout the body. The LDL cholesterol level in those with ApoE4 genes averages more than 40 points higher than those with ApoE2 genes, gunking up the arteries that feed both the heart and the brain. LDL cholesterol is a risk factor not just for heart disease, but Alzheimer's disease as well. Switch people to a diet lower in animal fat and cholesterol, though, and those LDL differences can disappear, nearly a 60-point drop in LDL. The difference in cholesterol level caused by the different ApoE genes can simply disappear if you eat a diet low enough in saturated fat and cholesterol. So diet can trump genetics. This may explain the so-called Nigerian paradox. If you inherit one ApoE4 gene, your risk of getting Alzheimer's may triple. If you get ApoE4 genes from both parents, which occurs in about 1 in 50 people in the US, you might end up with 9 times the risk. The highest frequency of the ApoE4 variant occurs in Nigerians, but they also have some of the lowest rates of Alzheimer's disease. How could that be? The population with the highest rate of the Alzheimer's gene has one of the lowest rates of Alzheimer's disease? This contradiction may be explained by Nigerians' extremely low blood cholesterol levels, thanks to a diet low in animal fat and consisting mainly of grains and vegetables. Humans may have evolved to maintain an LDL level of about 25, but the average in the Western world is approximately 120. It's no wonder heart disease is the leading cause of death in high-income countries, and Alzheimer's disease, according to the World Health Organization, is killer number 2. Too often, doctors and patients have a fatalistic approach to chronic degenerative diseases, and Alzheimer's is no exception. It's all in your genes, they say, and what will happen, will happen. But research shows that although you might have been dealt some poor genetic cards, you may be able to reshuffle the deck with diet.